Hello friends, today we are going to see the most basic topic of thermodynamics. It is law of thermodynamics. So the points we are going to cover in this tutorial are the three laws of thermodynamics, concept of entropy and its examples. So we will start with the first law of thermodynamics. It states that energy can neither be created nor destroyed. It can only be transformed from one form to other. What this statement means is that total energy of the universe is constant. Energy only gets transformed from one form to the other. There are so many things happening around us which are the best examples of first law of thermodynamics. So we will see few examples of the first law in the next slides. Photosynthesis. We all have learned about photosynthesis process in our school days that plants use sunlight which is falling over them for producing their food. So this is nothing but a conversion process in which light energy from the sun is converted into chemical energy. We'll move to the next example of windmill. We all know windmill operates on the wind flowing over it and converts kinetic energy of wind into electrical energy. So this is also one of the conversion process in which kinetic energy is transformed into electrical energy. And the last example of first law is diesel engine. The diesel engine which is used in railways, cars is also a best example of first law, that it converts chemical energy of diesel into kinetic energy. So after going through all the three examples, we can see that these all are related to conversion of energy from one form to other. Now before moving to the second law of thermodynamics, I would like to explain the term of entropy to you so that understanding of second law will be easy. So the entropy is basically the randomness in the system. Just keep this definition in mind and we will move on to the second law of thermodynamics and we'll try to understand it. So the second law states that the total entropy or the randomness of the system always increases over the period of time. This is just the statement. We will see the first example and we'll try to understand what exactly this statement means. So the example is melting of ice cube when it is kept outside of a refrigerator. It is one of the best example of the second law of thermodynamics. What happens when we put ice cube outside of the refrigerator? Since ice cube is at lower temperature than surroundings, the heat starts flowing from the surrounding to the ice cube, and as the temperature of ice cube starts to increase, it starts melting. So this is the natural phenomena we all know. But the question behind is this: in this, why this phenomena happened? Why heat do not flow from the ice cube to the surroundings? The reason is nothing but second law, as it states that entropy or the randomness of the system always keeps on increasing. So when the ice cube is in the solid state, there is very less randomness in the molecules. They are arranged in very specific format, or we can say in much ordered format than the liquid state. So as to follow the second law, the ice cube will try to achieve the state at which entropy is higher. So ice starts melting into the liquid state, and in liquid state molecules are more disordered than the solid state. Hence entropy of ice cube after period of time gets increased without any external aid. So the second law is applicable to all the things happening around us without any external aid, like heat energy coming from the sun to earth, water flowing over the dam. In all these examples, system tries to increase its entropy. Now the last third law of thermodynamics. This is the easiest law to understand if you are clear with the concept of entropy and second law of thermodynamics. As we have seen in second law of thermodynamics that it is universal tendency to keep on increasing the entropy. So the question is that at which point entropy is zero? The answer to this question is absolute zero temperature. And what is absolute zero temperature? It is minus 273 degrees Celsius temperature, and in practical it is impossible to reach this absolute zero temperature. So if we want the system to be more ordered, it should be maintained at absolute zero temperature, which is difficult thing to achieve. So friends, I have tried to explain all the basic laws of thermodynamics and hope that you have understood it well. If you still have any queries, please comment below. Thank you.